Hey guys, last video here I'm going to explain how to graph these functions. Okay, so again what we have to be able to do is identify the parent function of where this expression even came from, and then identify your parameters. This negative, which is an a value, right? It's not going to stretch the graph, but it's going to flip the graph upside down because it's a negative. We have x minus h, so since we're subtracting a 1, h is a positive 1, so it's going to move the graph, this absolute value parent function, to the right 1, and then the graph is going to move up 2. Okay, so let me grab my snipping tool, and let's graph this. So, a couple ways you can go about this. Using the transformation and parent function idea, if we think about the parent function as just the absolute value of x, so put in a number, take the absolute value of it, right? Put in a 0, absolute value is 0. Put in a 1, absolute value is 1. Put in a 2, absolute value is 2. It creates this line, right, that has this slope of 1. So this is our parent function on the right side. On the left side, put in a negative 1, get out of 1 still. Negative 1, positive 1, right? Put in a negative 2, get out of 2. Put in a negative 3, get out of 3. So really, it's this pattern also over here. And that's why that absolute value function is this V shape, because it's always a positive output. Okay, so the negative is going to take this graph, instead of getting out these positive outputs, now we put in a 1, we get out a negative 1. And put in a negative 5, we get out, instead of a positive 5, now we get out negative 5, right? Takes all these positive values and makes them negative. So that's going to flip our graph then upside down, right? This minus 1 here means our h is a positive 1, so the graph's going to move to the right 1, and then our positive 2 means k is a positive 2 here. So to graph this first one, what I think about is this vertex point 0, 0. Let's move it 1 unit to the right, since h is 1, and go up 2, since k is 2. So that point just translated to this point, and instead of going over 1, up 1, over 1, up 1, over 1, up 1, now the graph got flipped, so we'd go over 1, down 1, over 1, down 1, over 1, down 1. So this is actually what the graph looks like here, and then over 1, down 1, and we can see our graph looks like this. So there is our transformed graph. Okay, let's take a look at another one. Let's go to 17. Oops. Okay, let me grab this one. Okay, so now trying to identify the parent function here. We have a quantity with x in it. It's not getting squared, it's not getting cubed. These aren't absolute values. We're not raising 2 to this x minus 2 power. So this is going to be a linear pattern, right? This is going to be our parent function, just x. Put in a number, get out that number. So if you think about your parent function, put in a 0, get out a 0. Put in a 1, get out a 1. Put in a negative 2, get out a negative 2, right? So put in negative 1, get out negative 1. So this graph, your y equals x line, is just all the points where the x and the y coordinates are the same thing. That's where all lines start, right? So there's our parent function. So now what this says is let's move the graph over 2 units to the right. We're going to double the output, and then we're going to add 4. So let's, since it's a line, if we get 2 points, then we got the whole pattern, don't we? So what that means is let's look at this point here at 0, 0. Okay, since we're taking x minus 2, that means h is a positive 2, so we're going 2 units to the right, so h is here. Or excuse me, that point now translates to here. And then we're going to go, the output, we're going to double it. Well, getting out is 0. Doubling 0, we still get 0. So there's nothing going up or down since we're on the x-axis. But then we're going to add 4, so we're going to move the point up 4. So that point actually moves right there. Let's take another point. Let's take maybe this point here, right? It's going to do the same thing. Going to go 2 to the right. Now look at the output. So at this point, our output is 1, 2, 3, 4. So let's double that. So now we're going to go up, instead of going up 4, we go up 1, 2, 3, 4 more. And we're up here at 8, right? And then the graph even goes up 4 more in value. So right here. And then there's our 2 points to make the line. So our graph would look something like this. Okay, take a look at number 18. Okay, snipping tool. A few more of these guys and we are done. So this is going to be 3 raised to a power. So this, our parent function is going to be 3 raised to some power, 3 to the x, right? So 3 to the 0. Remember, anything to the 0 power is 1. If we let x be 1, we got 3 to the first power. So 3 to the first is 3. If x is 2, we get out of 9, right? 3 squared is 9, and so forth. And then on the back side here, we need to do some explanation here. But parent functions right now just have this kind of roller coaster feel to it. So we're going to take that. Looks like since we have a positive, that means that we're subtracting a -2. So h is -2. So we went 2 units to the left and then down 2. So this point here looks like it went 2 units to the left and then down 2. This point here, let me make a different color. Right here. This point went 2 units to the left and then down 2. This point here, 2 units to the left and then down 2. Right? And then our graph is just going to look something like this. Okay? Next one, if you needed to see that, go rewind that and then just pause it. Okay, the 19, we're taking a squaring pattern. We have x plus 1 squared. Okay, so let's get the snipping tool so I can draw this graph. So remember our squaring pattern. Our parent function is just take a number, square it. So 0 squared is 0. 1 squared is 1. 1 times 1, right? 2 squared is 4. 2 times 2. 2, 3, 4. 3 squared is 9. 3 times 3, right, is 9. And on the negative inputs, -1 squared is 1. -2 squared is still 4. -3 squared is still 9, right? So here's our parent curve, this parabolic curve we call it, quadratic, look. So now we're going to take this curve, we're going to move it 1 unit to the left. Since we're adding again, we're subtracting a -1. So h is -1. A in this case is 3. So we're going to take our output of the point, we're going to triple its position, okay? So let's do that. So let's take this point right here. Let's take this 1, 1. It went 1 unit to the left, so this point slid over here, 1 unit to the left, and now our output is going to triple. So notice the output at this point is 1, so now we triple that up to 3. So this point just went to that point. This point here goes to the left 1, and now its output is 1, 2, 3, 4. So if we triple that, we go up another 1, 2, 3, 4, 1, 2, 3, 4. So something like there, right? So this point. On the opposite side, we're going to have that same symmetric shape. So here basically is our quadratic curve. Moved 1 unit to the left. Oops, I didn't do that right today. This point here over 1 should look. Oops, this point needs to be over 1. My bad. It should look like this. There we go. Sorry, bad drawing there. And then the last one just says to write an expression where it takes the absolute value function, moves it around, and then let's just graph it. Okay, so I'll just do that on this right here. Oh no, it screws up my screencasting. So let me snip this. Okay, so we're going to take the absolute value function, right? So when we think about transforming, take our stretch number times the absolute value. Let's subtract off an h if we want it to move horizontally, and add some number if we want to move vertically, which is taking this parent function, by the way. And we're going to transform that around, right? So let's see here. It wants to move 2 units to the left. H is a -2 then. So x minus a -2 gives us an x plus 2. It's going to be stretched by a factor of 2, so a must be 2. And then it's going to move down 2. So there's our expression, right? So if you think about this, this point is going to go 2 units to the left, 1, 2. It's going to go down to, oops, 2 units, and then if we stretch this, don't we have, instead of having a slope of 1, does it make sense we're going to have a slope of 2? So over 1 instead of up 1, we go up to 2. Up 2, now we go up 4, right? So now our slope is stretched to 2. Right? Move this graph over 2 and then down 2. So over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2. So here is our graph. This one right here. There you go. So good luck with your graphing, guys. If that was too much of a mess, my graphing, it's hard to draw on these tablets, but if that didn't make much sense, make sure that you come and get some help on that. Good luck, guys.